Let's see units and dimensions of AC circuits, starting with Vrms. Vrms is equal to Vm by root 2, maximum value divided by root 2. Its unit, see, as it is voltage, we can write voltage is joule per coulomb. This joule per coulomb is also called volt. So these two are the units. Its dimensional formula of Vrms is same as that of voltage. It is m1 L2 t minus 3 a minus 1. I have derived this thing in chapter number 2 as well. So if you want to see the derivation of dimensional formula of voltage, you can see that in chapter number 2. I will suggest you to see all the videos in sequence so that you can learn it very easily. So this will be the dimensional formula of Vrms. Now let's see IRMS. IRMS is given by the formula Im by root 2, maximum value divided by root 2. Its unit is, obviously it is one of the 7 fundamental physical quantity, so therefore its unit will be ampere. Its dimensional formula will be A1. Next, inductive reactance. Inductive reactance is indicated as XL, and XL is equal to omega L. Okay, see, as it is reactance, its unit and dimensional formula will be same as that of resistance. So its unit will be ohm. Its dimensional formula will be, see, dimensional formula of XL. Dimensional formula of XL is same as that of dimensional formula of resistance, and that is equal to m1 L2 t minus 3 a minus 2. In terms of coulomb, if that MCQ is asked in terms of coulomb, then we can write m1 L2 t minus 1 q minus 2. So this was inductive reactance. Similarly, we have capacitive reactance. Capacitive reactance. See, remember, capacitive reactance and inductive reactance both have same unit and dimensions. Xc is equal to 1 by omega c. Its unit will be ohm. Its dimensional formula same. Xc will be same as that of resistance. That will be m1 L2 t minus 3 a minus 2. In terms of charge, again I am writing so that you can remember it well. m1 L2 t minus 1 q minus 2. Now impedance. Impedance is indicated as Z. The formula of Z is equal to Vrms by Irms. Sometimes Vm by Im. Also it is V by I. Also it is root of R square plus XL minus XC the whole square. So there are too many formulas for impedance. Now let's see its unit. This unit is ohm. This is dimensional formula. See, dimensional formula of impedance is same as that of resistance, and that is M1 L2 T minus 3 A minus 2. In terms of coulomb, we can say it is M1 L2 T minus 1 Q minus 2. Next is power. Power was there in mechanics also. We are talking about the power in AC circuits. So for AC circuits, power is given by the formula P is equal to voltage into current, and that is equal to Vrms Irms cos delta. Here this cos delta is called power factor. This is called power factor. So as this is power, its unit will be watt. What is the unit of power? If this is the question, then the answer is also what is the unit of power. Again, what is the unit of power? The answer will be what is the unit of power. So the unit of power is watt. Its dimensional formula quite simple. It is M1 L2 T minus 3. This is the dimensional formula of power. Now let's see power factor. Power factor Here this thing is called power factor. So I will write cos delta. Cos delta is the power factor. Its formula is cos delta is equal to R by Z. Both R and Z are having unit and dimensions of resistance. So therefore it will be unitless, and also it is dimensionless. So power factor is unitless and dimensionless, whereas power is having a unit of watt and its dimensional formula is m1L2 T minus C. So the power is not unitless and dimensionless, but power factor is unitless and dimensionless. Transformation ratio is there in transformers. Transformation ratio is given by the formula IR is equal to number of turns in secondary to the number of turns in primary is equal to voltage in secondary circuit to the voltage in primary circuit is equal to, remember, the current will be inverse IP by IS. This is the formula for transformation ratio. If transformation ratio R is greater than 1, then it is a step up transformer. If R is less than 1, then it is a kind of step down transformer. Okay, as it is the ratio of number of turns, number of we can say voltage in secondary to the primary, and is the ratio of current. So that's why it is a kind of unitless and dimensionless. So power factor is unitless and dimensionless. Resonant angular frequency. It is the frequency for which the current becomes maximum. Once again, the frequency for which current becomes maximum is called resonant angular frequency. It is given by the formula omega is equal to 1 by root of LC. When the circuit is at resonance, see, I'm writing down the equation. This V is given, so Irms is given by the formula V by root of R square plus XL minus XC the whole square. So when this term becomes 0, the current becomes maximum. So when this term becomes a 0, we can say XL is equal to XC. We can write omega L is equal to 1 by omega C. Therefore, omega square will be 1 by LC, and ultimately we will get omega is equal to 1 by root of LC. So when the current in the circuit becomes a maximum, that phenomena is called resonance, and the angular frequency at that point is called resonant angular frequency. As it is angular frequency, its unit and dimensional formula will be same as that of angular angular speed. So its unit will be radian per second. Its dimensional formula will be just T minus 1, because radian is a kind of supplementary quantity. Now let's see angular frequency, resonant frequency, just resonant frequency, not the angular one. This omega can be represented as a 2 pi f. I'm writing down the RHS as it is 1 by root of LC. So therefore the frequency becomes 1 by 2 pi root of LC. So as it is a frequency, its unit will be hertz, or second invert, its dimensional formula will be T minus 1. So this was all about all the units and dimensional formulas of chapter number 7 AC circuits. I hope you understood. Thanks a lot. All the best for your exams.